everyone, my name is Kenny. In this tutorial, I'll be talking about Apache Spark getting started. We'll be looking at different uses of Apache Spark, but our main focus will be on batch processing. So let's get started. So what is Apache Spark? Apache Spark is an open source distributed cluster computing framework. It is used for batch processing, stream processing, graph processing, and machine learning. So let's compare Apache Spark with Hadoop MapReduce. Apache Spark is 10 to 100 times faster than MapReduce. Apache Spark supports batch and near real-time processing, whereas MapReduce supports only batch processing. For processing location, Apache Spark uses in-memory by default with support for disk storage, but MapReduce uses only support disk storage. Apache Spark allows writing complex code which could be used for batch processing, stream processing, graph processing, and machine learning, whereas MapReduce only supports simple map and reduced tasks for batch processing. Focus for today. Yeah, we're going to be focusing on Apache Spark using Scala programming language for batch processing. We can also use R, Python, and Java. But for this presentation, we're going to be talking about Apache Spark with Scala. And our touch points, we're going to talk about Spark architecture with explanation, operations in Apache Spark batch processing program using dataset or data frame. For your interest, we won't be using RDD, resilient distributed data frame. It's low level, and we'll talk more about dataset or data frame. Then we'll be talking about Spark deployment modes, and also we'll show some sample codes, and we will have some deployment example as well. So the next slide shows the Spark architecture. Basically, within the Spark architecture, we have the master, we have the worker nodes, and the master nodes contains a driver program, which includes the Spark section and the user code. Then we also have the cluster manager and the worker nodes, which contains executors that run your scans. We'll see more about this in the next slide. So Spark architecture explained. Well, yes, Apache Spark uses the master-slave architecture with one master node and two or more worker or slave nodes. The master node contains the Spark driver, which converts your application into tasks and routes those tasks to a cluster manager, which could be Hadoop, Yarn, Apache Mesos, or Spark standalone. The cluster manager distributes tasks to worker nodes with executors that run tasks. Operations in Apache Spark batch processing program. The operations you can do with Spark doing batch processing is you can read one or multiple data from source into memory. You can transform the initial data you read to new data using join columns, select columns, add columns, rename columns, drop columns, union rows or filter rows. The basic SQL operations. And these transforms are lazily executed. That means that they are not executed until you perform an action, which we would talk about shortly. So the other thing we can do in Apache Spark batch processing is performance tuning to improve processing time. But we won't cover this in this tutorial or presentation. Then next, we can perform actions like count, collect, write, or on intermediate or final result. So basically, your actions are those things you do to generate results or to write to a database. So actions are eagerly executed. So the next slide we talk about this Spark deployment modes. So we can have the local mode, which is used to test the code, you can use to test your code with a small amount of data in a local environment. It helps in debugging the code by applying breakpoints while running in Eclipse or IntelliJ. Then we can also have another deployment mode, is the cluster or connected computers mode. So basically, within this mode, we have, a cluster is just a connection of computer that uh, can communicate with each other. So, so we can have this in standalone mode. Basically, the standalone mode uses built-in Spark cluster manager. Then we also have the Yarn. We can also use Yarn in. We can also use Spark in cluster mode as Yarn. This uses Hadoop Yarn as a cluster manager. It does Yarn client mode with Java modes running on client or local machines and tasks executed on worker nodes of the Yarn cluster, or Yarn cluster mode with Java nodes running on cluster master machine and tasks executed on worker nodes of the Yarn cluster as well. So the next slide we talk about will be talking about sample codes. Here is an example of a read operation. In this for this read, we read a semi-structured CSV data get from the baby names.csv, which is available online. You can see the reference as we go on in the in the slide we shared. So, within in this sample code, we have the package, which is demo app, and we also have we imported the Spark session. For you to import this Spark session, you must have added your dependencies to SBT. If you are using the SBT, or you can, if you are using Maven as well, but you need to add this a dependency for you to see the Spark session. And so within this code, the read code, we have the Scala code, which has the objects. For you to, if you want to learn more about Scala, you can send me a message. I could share with you some valuable resources. But there are so many tutorials online where you can learn about Scala. So we have the objects, which represents the driver program. Then within the driver program, we have the main method, and then we have the Spark session, the initialization of the Spark session, where we point to the master as local, the app name as Spark app, the demo, and we have the get or create method on that. For your interest, the Spark session is like connecting to a database. It gives you access to everything you need to interact with your data source and also to transform them and the like. So within a Spark program, you would definitely need a Spark session to start with. So after creating the Spark session, we have the inputs. We created the input parts, which points to the baby names. This file must exist within your application for you to see this part. Then we created the data frame, which is simply achieved by reading the file, the service file within in the input part. By the way, a data frame is just a tabular representation of data in memory. This is the way Spark works. So we have data frame. We also have data set, which is more typed, unlike data frame, which is not typed. By being typed, I mean you can actually, each of your columns can be represented by a class with, and this is one way of representing your data. So so that's that about the read operation. Then we talk about the transform. Like I said, transform is just a way of performing some operations on your on the data you read into memory, and this is essential. Like we can select rows, we can drop row, we can select uh, columns, we can drop rows, we can filter, and so many other things. I mean, we can join and the likes. So for the sample code on transformation, we do a simple transformation by selecting year, name, and sex of of, of babies from data in the red sample code. So here you see the sample code. Basically, we created a data frame called df2, uh, which which creates a new data frame with just three columns: year, name, and sex from the initial data frame df1. Then the next sample code is the write uh, operation, which is actually an action. Uh, we perform actions of counting. So in this particular case, we perform actions of counting on the records in the data and writing the first 10 records to a file in, in JSON format. So if you look at the sample code, the first thing we did was to count the data frame. By the way, we omitted some code which we already talked about, like the read and the transformation. So the final step of what we are doing is just the write. So we count the data. So this will show all the counts of data. Then we created an output file, the output.json file. Then we from a data frame we select the first 10 records, and then we write it to the JSON file. Then the mode of the write is overwrites. That means the data in your file will be overwritten each time you run this um, action. Other modes could be save mode, which you can use. So the next slide talks about deployment examples. For deployments, Spark execution with minimum data can be run in IntelliJ or Eclipse for test and debugging purpose. But for real deployment, they can be started on a cluster like standalone Yarn or Mesos using Spark Submit after creating a jar of the Spark application. So with uh, Spark Submit in submit mode, we have uh, this command line snippets where you have the Spark Submit with argument called class with an option called class. So within the for this option, you have to create the argument that points to your uh, driver uh, program. So we have the demo dot the package dot demo app drive, which we saw earlier. Then the next thing for your master, you have to specify the master node. Uh, this we will talk more in probably in subsequent slide. But for now, we are omitting this part. You can within your local machine or remote machine, you can create the master node and the slave node for your standalone mode. Then we have the deployment mode, which specify where your Java program will reside. For this case, the deployment node is a client, which says that your Java node will work within your computer. You can also have the deployment mode on the cluster, uh, which is the master node. So we'll learn see more about this when we talk about the the uh, yarn mode. Then we have the executor memory, which talks about the size of the executor. Like I said earlier, the worker node contains executors which run tasks. So you have to give certain amount of memory to the executor for them to run. because they will have to hold data and and run tasks, so they definitely need memory. Uh, and as you know, Spark is I said earlier, it uses in memory for processing by default, unless you specify disk storage for it to hold memory. And this is actually one of the benefit of Spark, because in memory is faster because it avoids the disk I/O issues. So the next we have to include the total number of executors. This is the number of CPU cores you want to have. Uh, Usually you can specify like 4 or 5, depending on your need, but uh, for this case we have 2. Then the next thing is that you have to specify the jar. For your Spark application, you need to compile it. You need to package it into a jar file. Uh, you can use if you are using SBT, you can do SBT clean package. If you are using Maven, you can use Maven package. Uh, these are all ways of creating your jar. Then the next deployment mode is the Spark Commit in Yarn client mode. This is one of the ways you can do Spark Commit if you are deploying your Spark application on Yarn. So here we do Spark Commit. We specify the class, which is demo.demo drive. The master is Yarn. Then we have the deployment mode, which is client. As I told you before, specifying client as your deployment mode means that your driver runs on your on your on your local machine. This has a benefit in that when your driver runs on your local machine, you can actually see the logs on your local machine. But if it's on the cluster, the master node which resides on the cluster, you will definitely not be able to see this unless you uh, log into your uh, Spark UI to see the logs. So for this case as well, the executor memory is 1 gig, and then the next one, the total executor cost is also 2. Then we also have the jar file. Then the other one is the Spark Submit in Yarn cluster mode. For this case, the class is demo app drive. The master is Yarn. The deployment mode is cluster. The executor memory is 1 gig, and the total executor cost is 2. And then we also have the demo app drive. That's all. Next slide shows references. Thank you.